Welcome to the talk, TimeTuner, Diagnosing Time Representations for Time Series Forecasting with Counterfactual Explanations. This is Jianing from the Hong Kong University of Science and Technology, Guangzhou. I will introduce my work in the following chapters. Time series forecasting is a crucial research problem with an increasing emphasis on leveraging deep learning techniques in recent years. However, DL models are often criticized for being overly complex and lacking interpretability, and their behavior is highly sensitive to the representation of time series data. As recognizing the significance of data representation learning has become increasingly popular in the DL domain. For different forecasting tasks, we usually apply different transformation methods and parameters such as smoothing, normalization, aggregation, and sampling to get suitable time series representations. So, the quest for intuitively choosing appropriate data representation methods is particularly crucial. The task is challenging due to the two main reasons. For model, current evaluation for time series limited to single metric, such as root mean square error for the training or testing dataset as whole. Besides, automated approaches are inadequate for uncovering relationship among variables, representations, and predictions, especially for multivariate time series data. What's more, the lack of interpretability of DL models hinders users from understanding how different transformation methods affect predictions. For visualization, DL-based time series forecasting involves commands in various aspects, such as multivariate variables, diverse transformation methods, and large volume time series data. Given the extensive range of transformation methods and the potential overlap issues that arise from the sliding window machinism, developing effective visualization techniques poses a significant challenge. Besides, the presentation of both explanation and prediction metrics needs consideration. We summarized a set of analytical tasks and categorized them into three data levels. First, for variable level exploration, we would like to examine the details of variables and identify associations among variables. Second, for representation level, we would like to compare different representations, analyze the association among representations, variables, and predictions. Last, for prediction level exploration, we would like to overview the overall patterns of predictions and detect the prediction outlier. We propose a visual analytics framework, TimeTuner, which mainly consists of 4 modules in 2 stages: data transformation, forecasting, and counterfactual explaining in the forecasting and explaining stage. In this work, TimeTuner is instituted with smoothing and sampling, which are commonly used transformation methods for time series data. In the interactive exploration stage, we propose a coordinated multiple view visual system. Counterfactual explanations helps explore the relationship between a model's input and output, which are combined with extensive visualization systems to better explore the insights of datasets. According to this research direction, our work employs counterfactual explanations to reveal the associations among variables, representations, and predictions. However, this is nevertheless a challenging task because DL-based time series forecasting involves components in various aspects, such as multivariate variables, diverse transformation methods, and large volume time series data. Existing time series visualization utilize vertical position or area to display data values, or map time series to pixel-wise visual elements. However, given the extensive range of transformation methods, the presentation of two-dimensional metrics, and the potential overlap issues that arise from the sliding window machinism, developing effective visualization techniques grew the need. We develop a coordinated multiple view system that mainly includes profile view, variable inspector view, temporal view, representation view, and prediction comparatory view. Variable inspector view support the exploration of relationships between a feature space of continuous or discrete input variables and the target value. We provide a partition-based correlation matrix that partitions a variable into regions using uniform partitioning and uses Massac plots to overview local relationships or pairwise variable or representations. Temporal view is designed to visualize details of different time series representations for univariate data and variables for multivariate data. It consists of two parts: horizon graphs for the context information and a line chart for the detail. Representation view is used to compare different representations, meanwhile depicting associations between representations and predictions simultaneously. We propose a novel design of juxtaposed bivariate strips. The two-dimensional metrics of each sliding window are encoded using a VSUP to conduct more careful inspection of error-high slices and compare them. We considered three alternative designs. However, these designs are less scalable than the proposed bivariate juxtaposed strips, especially when the number of representations increase due to the increasing number of transformation methods and their parameters. Prediction comparator view is designed to review the relationship between explanation metrics and performance metrics, and subsequently analyze prediction outliers. Each prediction can be represented as a point in the scatterplot and encoded based on two-dimensional values schemed using the same VSUP with that in representation view. We evaluate the feasibility of TimeTuner with two cases. In the first case, the univariate sunspots forecasting, we notice that the periodicity of the sunspot dataset consists 1 month, 3 months, half a year, and 13 months. So we choose the smoothing method based on these 4 parameters and set these 4 parameters as the skip length. From overview in profile view or strips in representation view, we identify the representation WMA13 skip 3 achieves the highest prediction accuracy, and the presentation MA3 skip 1 has the largest training error. Besides, we notice that almost all representations have large slice errors between 2009 to 2018 because 2009 is a period of minimum solar activity and the model does not capture the weakness of sunspot activity. In the second case, multivariate PM2.5 forecasting, we focus on the multivariate air pollutant dataset. We can explore the relationship between different variable pairs for PM2.5. There exists a negative correlation between PM2.5 and temperature, and a positive correlation with relative humidity. We can observe from the wind direction wind speed plot that low wind speed hinder contaminant dispersion, resulting in high PM2.5 concentrations. The exhibiting elevated PM2.5 levels with high-speed south wind may stem from significant pollutant sources like factories and coal-fired power plants in the southern area. It can be obvious that there exist high prediction errors between January 13, 2014 to February 2, 2014, which may be due to setting off fireworks during the Chinese New Year. The outlier caused by the specific events are difficult to be captured and learned by models, resulting in poor performance of all models in this time interval. To evaluate the feasibility of TimeTuner, we collect feedback from 5 DL experts and 5 visualization experts. All experts commended the combination of counterfactual explanations with visual analytics for analyzing the impact of time series representations on LSTM-based predictions, and praised the system for its ability to support the exploration of both univariate and multivariate data. Our analysis uncovers valuable insights, providing useful hints for selecting appropriate transformation methods, and explaining why models perform poorly. What's more, our work has highlighted the significant potential of counterfactual explanations combined with visual analytics in advancing the field of data representation learning. That's all. Thanks for listening.